Good afternoon, class. I wanted to go over a couple of the topics that were covered in the exam where it seemed like there was a lot of confusion. And one of those was explicit versus implicit casting, which came up in question number 9. A lot of you were trying to explain the difference between the using casting with is and using parenthetical casting, as one of them being explicit and one of them being implicit. And that is actually completely off base because they're both explicit casts. But to understand the difference between implicit and explicit casting, let's very quickly kind of talk about what those actually mean. So explicit means that something is right out there. You're putting it out and you're making it very clear of what something is. So it's explicit. Implicit, same base word root as implies, is you're not actually putting it out there. It's just implied that that's the case. That's really kind of the way to think about those two words. So what is implicit casting? Well, let's say, for example, I declare a integer. So int a equals 10. That's pretty straightforward. Now if I declare a decimal and I set it equal to A is an int, B is a decimal, and if we run this code, notice that it happily says, okay, yeah, I can put 10 into a decimal shaped hole. So I can take an integer and put it in a decimal. And the reason I can do that is I'm not losing any information when I put an integer into a decimal. I'm actually now specifying that the decimal B is going to be 10.0. No different than 10, same value. So this is what we call an implicit cast, because the compiler just says, oh yeah, I can do that, that's not a problem. So any cast that you can do without explicitly stating that you're casting a variable is an implicit cast. Now if I were to flip that and say I want to create an int C and set it equal to B, well, B is now a decimal, and if I try to go into C, it's going to tell us we cannot implicitly convert type. Notice, again, we're saying implicit. This is attempting an implicit cast to make that decimal back into an int. An explicit conversion exists, so we know how to convert it, but we won't do it automatically unless you specifically tell us to. And we do that, again, by doing a parenthetical cast. So we say we want this to be an int. What we're actually telling the compiler when we do this is we're saying, yes, I know there's a chance some information is going to get lost. Like if that decimal had a fractional part, so it was 12.76, that 0.76 will get thrown away when we cast this to be an int. We are telling the compiler, yes, I know that's the case, I am okay with that. That's what makes it explicit, because we spelled out to the compiler that we understood that we were going to be changing this form. Now, one of the things that is important to understand, explicit and implicit casting are very much a part of most programming languages. There are a handful of languages, like Kotlin, for example, if you want to do Android programming, that actually have no implicit casting. They've realized that that is a potential place for misunderstandings to creep in, and therefore they make the programmer explicitly cast everything, including integers, into floating point numbers and things like that, because they're trying to make sure that it's always clear. Kotlin is what we call a strongly typed language, so every time you change a type you have to explicitly do so and make it very clear that that's what you're after. But that's the difference between implicit and explicit casting, so I hope that clears that up a little bit. Now let's talk about the two casting approaches that were actually asked about in question 9. So the questions were, what's the difference between the is keyword or casting parenthetically? So here let's just have, say we're going to create a variable of type fruit, and we're going to set a new banana in it. And if I run this, notice that works perfectly fine, because this is what we call again, an implicit cast. A banana is derived from fruit, therefore we can treat it as a fruit. That's not a problem. Going the other direction is where it gets a little more complicated. So if I create a banana variable and call it b and equal f, Now we're back to an explicit cast. We don't know for sure that we can do this. The compiler says, I don't know how that I can do that. There is an explicit conversion. So I could cast it this way by saying it is a banana. And if I run that, it's happy. Or I can do it with the as keyword. And it's happy. In both cases, what I'm actually doing is creating a new variable which is pointing at where this banana is stored in memory. In actually all these cases, from the moment I construct it, I create a banana-sized space in memory that I'm storing all the banana information in. A part of that banana-sized memory is fruit-shaped, because it's derived from fruit. So all the state of a fruit plus all the state of the banana, you can kind of think of it as a box in a box. I am holding both the information that makes it a fruit and the information that makes it a banana. Now when I treat it as a fruit, I'm really only looking at the chunk of that memory space that is specific to the fruit, and I ignore the fact that there's also some banana information there. When I cast it back to be a banana, I am now looking at the fruit space and the banana space. So the variables f, the variable b, those are both just references pointing at that one location in memory where the banana and the fruit information are laid out. And that's why we could treat it as either one, is because all that information is there. But if I add another kind of fruit, an orange, so now I have banana and orange, and I were to try to treat this f variable, which we know is a banana, as a orange, that's where things are going to go a little south on us. So if I run this, we get, oops, if I do that correctly, if I'm casting our fruit variable to be an orange, I get an invalid cast exception. This throws an error saying I can't turn a banana into an orange. They both have fruit information, but this actually has banana information, not orange information. I can't make those two glom together. It doesn't work. And that's what happens with the parenthetical cast, is it will throw an exception if the cast is not possible. If I go the other way and use the as keyword, and I run this, it will instead assign a value of, let's see what O is. O is going to be null. Notice no exception. It just sets it to be a null value. We don't actually get to see, because it's null, it's not actually printing anything out. So in that case, we don't throw an exception. Instead, we set that reference to null. And that's really the big difference here, is that if the cast is not possible, that's where the two keywords or two casting operations vary in how they behave. Also, the as cast only works with reference types. You can't do it with a value. So if we go back to our ints here, we can't say int d equals b as int. Notice it underlines it in red. It says we can only do that with a nullable type. Remember, value types are not null. They can't be null unless we make them explicitly nullable, so this will not work. If I turn this into a nullable int by throwing that question mark after it, then it might be okay with that, but it looks like even that doesn't like it. Yeah, so you just can't use it with value types. It has to be basically an object is really what we're talking about there. All right, so that hopefully helps clear up any questions you have about that. Remember, explicit casting means you're explicitly telling the program that you're going to perform the cast. Implicit means the program just does the cast for you because it's not throwing away any information, or there's not a question about is that actually something I can do. And remember, these kinds of casting errors, exceptions, or not being able to cast, explicit casting is done at runtime. So the Visual Studio debugging process won't find the problem. It's only when you run the program that that problem is going to crop up. And that's very important to understand, is that I can say something like this, but until I run that program, it's not going to cause a problem. Same here. That exception is thrown at runtime when the program is actually running. All right, I think that's everything I wanted to talk about on that one. So we will see you later.